The surface area and volume of a right cone are shown. R is the radius of the circular base, h is the height of the apex, and s is the slant height of the side of the cone. A particular cone has a height that is √3 times larger than the radius. Can we write the surface area and volume formulae as single variable functions? Let's inspect the variables used to calculate surface area and volume. The surface area formula has two variables, r and s. The volume formula has two variables, r and h. The surface area and volume formulae have two variables, so they may not be written as single variable functions. In part B, we'll express the apex height in terms of r. The question tells us that a particular cone has a height that is √3 times larger than the radius. This means we can write h equals √3 times r. In part C, we'll express the slant height in terms of r. We have a right triangle, so let's use the Pythagorean theorem to express the slant height in terms of r. For the triangle in this problem, we have s squared equals r squared plus h squared. Replace h with √3 times r. Square the term √3 times r to get 3r squared. Collect like terms to get 4r squared. Square root both sides to get s equals 2r. Note that we only need the positive case of the square root. We will not be dealing with negative radii or slant heights. In part D, rewrite both the surface area and volume formulae so they are single variable functions of r. The surface area formula is shown. Replace s with 2r. Simplify. Collect like terms. The surface area is 3 pi r squared. We have rewritten the surface area formula so it only has one variable, r. We may now use function notation to represent the surface area. Now we'll look at the volume formula. Replace h with √3 times r. Simplify to get √3 over 3 times pi r cubed. We have rewritten the volume formula so it has only one variable, r. We may now use function notation to represent the volume. Now we'll move on to part E. Use a function operation to determine the surface area to volume ratio of the cone. Divide the surface area by the volume to get the surface area to volume ratio. The surface area is 3 pi r squared, and the volume is √3 pi r cubed over 3. Multiply the numerator by the reciprocal of the denominator. Multiply the numerators and multiply the denominators. Use cancelling to simplify the expression. Now we'll rationalize the denominator. Multiply the numerator and denominator by root 3. Multiply the numerators and multiply the denominators. The surface area to volume ratio for a cone is 3 root 3 over r. Now we'll move on to part F. If the radius of the base of the cone is 6 meters, find the exact value of the surface area to volume ratio. Begin with the result from part E. The radius of the base of the cone is 6 units, so replace the function input with 6. Reduce the fraction to get root 3 over 2. This is the surface area to volume ratio.